This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host.
And welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology.
On today's episode, Zero Trust Networking with OpenZiti, with one of its community leaders, Philip Griffith. Philip, welcome to the show.
Pleasure to be with you, Darren. Thank you.
Hey, Philip, we had a brief conversation about what's going on with you and with the problem space around Zero Trust. But before we dive into that, my audience loves to hear about who they're listening to today. So give us the quick and dirty on who is Philip Griffiths.
Yeah, it's an interesting one. Let's start with my origin. Non-technical by training, literally did a degree in history. So if you want to do another podcast on World War II, Cold War, would love to do that. But I got into IT on a graduate program, project manager. And I basically discovered in order to be a good project manager, I had to know what my technical people were talking about, and they weren't lying to me or skewing what they were saying for their benefit. And so I just became more and more technical. And as I've gone through, I ended up joining a company that I thought was doing some really cool stuff in Zero Trust. At the time, I was like, what even is Zero Trust? This was 2018. Most people didn't know what it was. And I had to educate myself a lot, learn lots of things. It's been really interesting. I think it's a unique perspective because in order to do that, you have to understand how lots of other technologies work. And it's really the intersection of many technologies that is very crucial to Zero Trust, because it's not just a network or an application or a device. It's the whole landscape, the whole digital systems.
So before we dive into that, I think it's really interesting because I have a daughter. I've got 10 kids. So, and all of my sons have moved into the IT world, either computer science, electrical engineering, or IT. All of them have done that. And then all my daughters have been teachers, except this one daughter. She was a history major like you. She's now a product manager at a high-tech company. Yes. So maybe there's something about, history majors in product management.
I think there is. The history gives you a unique perspective where A, you have to understand language, and as humans, language is very important. And then B, you're always asking why. And why is a very important question for asking
there you go.
Management or something like that.
I thought it's funny because her specialty was the Cold War and World War II. So we went to London and saw all the great sites. She wanted to see Churchill's bunker. And I said, you don't want to go to the Tower of London? No, I want to go to the, Churchill's bunker. I'm like,
it's
okay.
The bunker.
Yeah.
Better weather.
So, that was pretty fast. All right. So let's dive into this whole concept of Zero Trust. So you being a newbie to the IT world, I'm going to call you a newbie though, because you're a history guy, right? So I think this is wonderful because you first heard Zero Trust and you're like going, interesting. So what is it that drew you in to working in this specific part of high tech?
So what drew me in was understanding more and more about digital systems. And specifically the role I had before joining this company was doing partner management for a managed services company, but specifically in the area of IoT. And at the time they were going, well, how do we manage services around IoT? What an interesting area. And I remember going to a customer meeting where we're talking to a water company, and people turn on the tap and they go, oh, just water will come out. And then you speak to these people about their problems around how their water systems work. You're like, oh my God, the world is so complicated. And you see these digital systems, all these systems becoming increasingly digitized, and to the point where our world nowadays runs on digital systems, and there's silicon everywhere making decisions. And now we call it edge and IoT, but we just used to call it distributed systems and OT back then. And this is a massive opportunity. Everyone talks, well, at least everyone used to talk about digital transformation. Now everyone talks about AI. But when people used to go digital transformation, you saw a lot of organizations who go, well, we want to do this digital transformation. And maybe when we do a POC, it's like really great. But as we look to scale it and take it to production, all of a sudden these non-functional requirements like security and connectivity and resilience and uptime, these are now critical topics. And so through this lens, I saw the start of zero trust and how we could apply it to things. I thought, oh yeah, this is really interesting, because this potentially, if we do it right, allows us to start building digital systems which can be secure by default. And this is like the kind of hot new words coming out of CISA and NIST at the moment around how to build secure by design, secure by default applications. And in my opinion, if you do zero trust correctly, you're not having a conversation around SASE or SSE as you know, certain analyst firms may have you believe. Instead, you're talking about secure by default. And for me, that therefore enables profound transformations that previously either weren't possible or weren't viable. And thus why it's important to do zero trust from the start correctly.
So it sounds like zero trust, and I've had several people talk about this already. But from your perspective, zero trust is very all inclusive. So you're taking a very much tops down approach to doing this, right? Because it touches every aspect of your OT or IT environments. Is that what I'm hearing you say?
Yes and no. And the reason I would say no is because, again, I am opinionated through the company and the projects I work on. But we have an internal mantra, which is permissionless innovation. And let's take an example. What was it now? Like 12, 13 years ago, AWS came along and went, you can just spin up your own, resources. No,
Oh yeah.
that's
Yeah.
crazy. No one wants that. And now you look back, you're like, well, it was obvious.
Oh, as a developer, we all wanted it.
And we have the same idea of permissionless innovation and ability for developers to make their applications secure by default. So yes, you may have the kind of top-down CISA, NIST, US government, CIOs, etc., saying, "Hey, we need some zero trust. We need to make things more secure." But simultaneously, our mantra is, let's make the best zero trust networking platform, but let's give it away for free and open source. Let's make it so that developers can just pick it up. And in fact, we had someone on our discourse the other day. It was like, I love this project because now I just build stuff, and I don't have to worry about managing firewall ports or going to the network team or the security team, because I make my application secure by default. And so you need the top down, the regulations, the pushing into the strategy of an organization, but you also need to make it so that people who are building stuff, people who are the coalface, can just adopt a library and get their work done. Because ultimately, someone's not coming to them and saying, "Oh, let's think about NIST 800-207." They're going, "How do I push out this functionality? How do I get this product to market as quickly as possible?" And by being able to create secure by default, they can just focus on their features and boom, 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 get the features out and not worry about is it secure as it goes to production.
So you're sitting in the area that there's this constant battle between the security engineers and the software engineers, right?
Yes.
Because the software engineer, and I'm a software engineer by trade, right? I hate it when all my ports are shut down and I can't get what I need to get,
Yeah.
right? Or I'm building a package and it's downloading stuff off the internet, and I'm like, I just need to get my work done. And the security guys are like, well, you don't know where that package came from. No, you can trust everyone on the internet. That's what software developers are thinking, right? Log4j, great example, right? Hey, everyone uses Log4j. It's free. And free for hackers to, hack on it too. So I see the dilemma, but what you're saying is with your concept, if I'm secure by design, if I'm secure up front, then the security is not in my way. It actually is enabling. Is that?
I would agree so. And it's really like, if you look at with cloud, we then had DevOps, and then everyone go, well, DevSecOps. And DevSecOps really brought together the development team and the security team and the operations team. But no one went, how do we bring the networking team into this? And so in our view, doing zero trust networking by default, so that the development team can just pick it up and then the operations team run it, and then the security team goes, great, this ticks all our boxes. We make our app dark. We make sure we don't have to deal with complex firewalls. In fact, we have no inbound firewall ports. That enables those four teams to really work together to rapidly build secure distributed applications, which tends to be what everyone's building nowadays.
So does it alleviate the need? Because when we talk about zero trust, there's always, before zero trust, right? We always had this fortress concept, right? we put the firewall around my data center. It's totally protected. That's my fortress. With zero trust, we're like saying, well, I don't trust anyone inside my fortress either.
Yep.
Right. So what you're saying, help me figure this out. What I'm hearing is I don't need that fortress wall anymore because I'm making everything inside zero trust. So I trust no one inside. Is that?
I'm going to say no, but with a massive caveat and star, which is
Okay.
Good security is defense in depth. Doing zero trust well gives you very good defense in depth. Does that mean I don't need any perimeter defense or firewalls? No.
No,
But
I should still need those.
like if you look at firewalls were invented in buildings as part of building codes in like the 1920s to stop fires from spreading. And people in computing went, oh, that's a good idea. Let's put them into computing. And they went, oh, and we're going to serve up applications in. So boom, 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 boom. Let's punch a bunch of holes in them. And then Log4j comes along and, whoa, we can potentially get exploited. Or move IT. Oh, we've been exploited. Who would have thought? Because we put it on the internet. And so if you do zero trust well, use your firewall how it should be intended. Block all inbound connections, not just TCP connections, but UDP connections as well. Potentially, you can block all outbound connections except for the zero trust overlay. Even if malware gets into my LAN environment, it cannot connect to command and control or exfiltrate data. Most importantly, from our perspective, at least, again, I am biased, our opinion is that if you implement zero trust correctly, you assume the network to be compromised and hostile. Therefore, why would you trust IP addresses, public DNS, and other network identifiers that we use today? Why would you trust the firewall? Just treat it to block all inbound. Therefore, you want to move zero trust or overlay networking built upon strong zero trust principles, identity, microsegmentation, deny by default, and move it as close to the application as possible. If you can move it into your DMZ, great, you don't trust the internet or the wide area network. If you can move it into your host, you don't trust the LAN as well. If you can actually build it into your application using a software development kit, now I don't even trust the host OS network. So even if malware gets onto my host, it can't break into the zero trust network and laterally move. And so it's all about how can we lock down the implicit and explicit trust that we normally give to the network at certain points, and instead make us secure by default from the external network.
Okay, I'm starting to understand this. So you guys have created this whole concept of an overlay network that is obviously software defined because it is by definition. It's an overlay network. So it's a virtual type of network that sits across, because not everyone understands what an overlay network is. I happen to understand a little bit because I play around with Docker containers and Kubernetes and Istio and all that stuff. So can you give us a brief description of what is this overlay network concept and how it helps me be more secure?
Yes. And I will start by describing underlay networks. Underlay networks are our routers and our firewalls and the cables that connect those systems. It's basically, I want to have a video conference with Darren on this podcast. We have a bunch of network components between us which are connecting. And we've probably got, I'm just looking on my browser. I assume it's HTTPS as a connection between us. So there is an underlay network that now enables us to connect together. That is the beauty of the internet. It's a wonderful underlay network. The problem is, something like 20% of packets on the internet are malicious. If you put something on the internet unprotected, it'll be hacked in like seconds. And so we use overlay networks in order to connect two resources without them being in the same local network. So a VPN is an overlay network. WireGuard is an overlay network. MPLS is a mixture of underlay and overlay. We use overlay networks because it allows us to say, I explicitly do not trust the underlay. I'm able to access resources, or I'm able to have an application or a data system be able to communicate from there to there, and I don't have to configure the networks in between. I don't have to trust those networks in between. I'm able to make it that even if the underlay network becomes compromised between them, the malicious actor can't see the data. They can't see the metadata. They're not able to effectively see the data that is transiting, or potentially even orchestrate an attack, because you're able to build an overlay network which doesn't trust the underlay and which operates in a ephemeral basis, so it can reorganize itself based upon what the conditions that are happening.
All right, so that's pretty cool when you think about it, right? Because I'm using the current physical infrastructure. I'm creating a new network across it that I have total control over. I know who I'm talking to, when I'm talking to them. So that to me sounds super secure. Why haven't we done this for decades?
That's a really good question. I get asked all the time, and I don't think people figured it. Like we built the internet, it's wonderful, and then everyone went, oh, it's not quite right, so let's build some firewalls. Oh, that's not quite right, let's do next gen firewalls. Oh, that's not quite right, let's do MPLS. Oh, let's do a VPN. We kind of incrementally tried to make improvements, and in fact, that was part of the reason behind us starting the company, because we went, we could make a better VPN. We could try to do, as we like to call it, Zero Trust 1.0, which is like, a VPN and some firewall functions to do some filtering and check device posture, etc. But we thought, what does it look like if you go to first principles? And to me, in proper Elon Musk style, the first principles is there is no such thing as a secure network. Networks are designed to share packets between A and B. And more important,
yeah.
We actually don't care about securing the network. We care about securing the applications and the data. We use the network, pun not intended, as a proxy to say, how can we move the packets between those resources and try to make them secure? The only thing you can do is create an isolated or private network. And we used to do this with MPLS, but that is not relevant as software eats the world. And so we went, right, so if those are all the problem statements, what if we make it so we build an overlay network that can be inside our application or inside our data system, allow connectivity, and explicitly not trust the network at all, and not have to have any trust in the network at all. And so I wrote a blog actually recently comparing zero trust using Harry Potter analogies. And that ultimate conclusion is effectively, I hope your audience is familiar with Harry Potter, otherwise it'll be war.
Oh, who isn't, right? Yeah,
that conclusion is, I can give my applications, I can give my data systems an invisibility cloak. So the network, the silly muggles can't find it and hack it. And as I move packets between whatever resources are, it's with a port key. It just magically happens. You don't need to know how the port key works. It's got a spell on it, and the package goes, whoop, okay, yeah, I've gone from my source to my destination, because you're able to abstract away having to actually configure DNS and IP addresses and routes and VLANs and all that stuff, because you're not trusting the network. You're building that capability into the application, or as close to the application and system as possible, so that you have that abstraction. You have that security by default.
Gotcha. This is really fascinating, and I love the analogy. By the way, I think it's pretty clever. How do I, as a developer, do I have to now rewrite my code to take advantage of this, or is this something that I can take existing code and run on top of, or what? Am I going to have to change the way I've done things? I mean. Yeah. First off, if I'm hard coding IP addresses, I'm an idiot anyway, right? But that happens, right? Because I'm in a hurry. I do that sometimes. But how do I take advantage of these overlay networks? How do I take advantage of this zero trust?
So the easy answer is to say you have a load of options, and it depends upon what is best for you. You could, and you have to also break this down in both client and server side. The technology which we use, which we call OpenZiti, it has no concept of client or server. It can facilitate anything and everything. That said, there is always going to be a consumer and a publisher. And so on the server side, you may say, hey, I don't want to change my application at all. Therefore, I'm going to deploy effectively a virtual appliance in the VNet, VPC, DMZ, whatever. Or you may say, I don't want to touch my code at all, so I'm going to deploy onto the host. And now I terminate zero trust and MTLS and end-to-end encryption, all those lovely things there. You may, though, say, I want to be app embedded. Great, take an SDK. If you're in Golang, .NET Listener, if you're in Java, I don't know how Java works. You're in Python, you're doing
or Node.js.
Some way in which you say, hey, these packets are going to come over ZT rather than, they're going to go to the port, the underlying port on whatever asynchronous connection. There is another option, at least on Linux, where you can do app embedded without actually embedding software into your application by using preload, one of the cool functions of Linux. And so server side, both depends. Some people want to go app embedded because it gives them the best solution, and it's actually, we've made it really easy. Some people don't want to go app embedded because they don't want to change their application code. Client side, again, you've got both options. Maybe you want people to use the, let's call it better VPN where it sits on their device. But we also have a client, I say clientless endpoint. It's not actually clientless because it does, it sits in the browser. It does authentication authorization before connectivity based upon strong identity. But from a user perspective, it seems clientless. Because we do magic in the background, so you don't have to use a plugin from Chrome or whatever the browser you're using. And then we also have options where you just throw something on the public internet. I want to share a webhook. I want to share a web page or a file or something like that. So both sides, you've got loads of options. There's another one, which is we've taken some popular open source systems and we've already pre-embedded our code into it to be able to go, oh, here's app, zero trust embedded SSH, or here's zero trust embedded Prometheus, or whatever popular.
So you've taken some of the more popular.
Yeah, we take that binary, put our code inside it. Poof! Now it's working.
Sounds to me like I can. Let's say I'm a sysadmin, because I used to be a sysadmin too, right? And I need to implement zero trust. I can take this, I can install it on my servers and deploy my applications utilizing it without a change to the application. I can do that. See, that's highly beneficial, right? Because I don't have a lot of code to rewrite. And sometimes I've got code that the developers don't exist anymore.
Yes.
Right. I mean, let's be honest. They've left the company, or I got some old COBOL stuff where no one's even alive that can even maintain it anymore. Yeah. But so I don't have to write it in code. I can do it at the system level, and provide zero trust. So this is highly beneficial. I like the integration points across the whole spectrum.
Yeah. I think for us, it comes down to who the system user is. If you run systems but don't have access to the code, you're most likely going to not change the code at all. If you manage the application, then maybe you don't start with application embedded, but that should be your North Star. Because if you do that, your users can then use the system and they don't have to worry about it. It's just part of your binary. It's part of the application.
It's just part of it.
And so this is this is something we're doing recently with EdgeX. EdgeX is a popular open source edge runtime, part of the Linux Foundation, which Intel does a lot of contribution to. So a lot of the engineers working on are Intel employees. And as they move to their 3.0 architecture, specifically 3.2 Odessa, which I think gets released in March next year, they're seeing more deployments where EdgeX is distributed across the network, on the edge, connecting to the cloud, etc. And so to make that just super easy for their users of the system, they've embedded Ziti using our Go SDK because their system is all written in Go. So that if you want to just click on that capability, you click the tick box and poof, you've now got native zero trust embedded into the distributed system, so that you get end-to-end encryption, you get mutual TLS, you get strong authentication, authorization, all of these wonderful things just automatically turned on for you. So you don't have to go, well, how do I roll my own zero trust? How do I do that? How do I run my own CAs? How do I do all this stuff? You're just able to turn it on. I have in mind a future marketing campaign, which is definitely not stolen from Intel, around Ziti being inside, like Ziti inside, like each application will be proud. We've got
definitely not stolen from Intel. That's pretty funny. Okay, so let's talk about features of OpenZiti. Right, I think I understand how I can utilize it. To me, it sounds like it's a great zero trust library with all of the bells and whistles for zero trust security built in. So if I can leverage it, I most definitely will. Why would I write my own authentication server? Why would I write my key management stuff? I've done that. It's a pain in the butt. It really is. It's a pain. So OpenZiti gives me all that. What other features does OpenZiti give? Does it give the visibility, auditability? Does it give those things too? Or does it rely on third-party things to plug into it?
Good question. So I will preface by saying we've built Ziti to be extensible and orthogonal. So it can always interact with external systems, and it should, because Ziti doesn't do everything. Particularly if you break down zero trust into all different pillars, there are components which we're not doing, where we need to interact with third parties and external APIs. What ZT does give you is an overlay network built upon strong zero trust principles. So that starts with ZT having its own identity system, CA, PKI. There's many other providers that defer to external IDP, but we don't think that's a good solution, because if you go into edge IoT machines, they don't have IDPs. There's no Azure AD, there's no Okta. And so we thought the system has to have its own identity system using X509 certificates, but you can bring an external one. You want to come with OICD or SAML, great. We'll just defer to that. But we start with our own identity system. That then implements tunneling, so you get mutual TLS, you get end-to-end encryption. You can make it FIPS compliant if you want for your use case. You get posture check, so you can check the device security like MFA, TOTP, or domain join, AD, admin, etc. What OS am I running? You have the ability to set up very coarse tunnels like 0.0.0/0 or /1, everything.
Right. Yeah. Everyone can talk to everyone.
Specific DNS. So micro-segmented, least privileged access based upon deny by default. You get a private DNS, so you can route. You could put in Cloudflare, and the packets won't go to Cloudflare; they'll go over OpenZiti. Or you could put, here's a silly, stupid DNS name, and it'll intercept that and take it to wherever your service terminates. Which means you can solve overlapping IP addresses. It makes outbound connections, so you solve any NAT issues. ZT also has a smart routing fabric, so that a good way to describe it is actually, if you're familiar, MPLS, what we used to do with physical wires and hardware, ZT does as software. So you can input policy and tell it how to route, and it runs algorithms to figure out, what's the fastest way to get from left to right, with as little performance degradation as possible. And there's some clever things we do to speed up, or at least to lose as little as possible, because overlays do introduce some overhead. And then there's a whole bunch of things around visibility of, when does a connection fail? Therefore, I can infer how the underlay is running, where a misconfiguration may be in the underlay. Visibility on how all the connections are running, so I can see, is my latency coming from telco 1 or telco 2, or is it coming from the internet, or is it coming from the local? And lots of visibility, particularly at a kind of OSI stack 3 to 5. You have crazy intelligence as to, even though ZT isn't trusting the IPs, here's a bunch of information as to how the packets are moving through the overlay, how it's going through the underlay, which allows you to you can control the underlay even if you don't own the underlay, because you're able to build intelligence and routability into the overlay network. I'm now cognizant I said overlay like 1 trillion times in that.
I think we get it. Overlay. When I worked in the container ecosystem, they always talk about Docker has it, Kubernetes has overlay networks. So why would I use your stuff instead of what's already built into, into Docker or into Kubernetes?
So I am going to preface by saying I'm not an expert in this area, but I am opinionated. I like to just riff off. So I might be wrong.
I like opinionated people.
But Kubernetes, Docker out the box don't have overlay networking. That's why service meshes were created. That's why Cilium and Istio and all these capabilities exist. Of how do I do Kubernetes but enforce mutual TLS? How do I enforce authentication and authorization? And so there are ecosystem components which can provide that, but most of those components are focused on layer 7 HTTP, HTTPS type capabilities. So what if I've got UDP or another layer 4 or protocol that's non-HTTP? Well, tough. Also, they focus very much on east-west connectivity within the LAN.
Within the
and they tend to also be focused on purely Kubernetes use cases. And so, if you need to do a TCP connection between Kubernetes and a non-Kubernetes system across the wide area network.
Oh no, it's a nightmare.
For that. Whereas we built ZT, OpenZiti, as a platform to facilitate any use case, and so it is really awesome across the WAN, north-south, as we used to call it in the traditional data center setting. Particularly because it has that smart routing fabric. It definitely gives you a high level of security because you're doing those outbound connections. You've got much more obfuscation and end-to-end security, much more of a deny by default zero trust approach. But it also has the ability to do east-west. And so, ZT doesn't replace service mesh. We have some people that use it, ZT together with service mesh. We have some people that are deploying on, well, why would I need service mesh? Because I've already got most.
Because I've got
it's kind of horses for courses, depending upon what your requirements are, whether it's used together, used instead, and any mixture of.
No, I like what you said there, because that's a key differentiator. Is it can work across the WAN. It can work not just in one ecosystem. So another quick question, and then we got to ask you about your shirt, because it's a unique shirt. So we got to. But one more question has to do with operating in semi or disconnected states, because especially when you mention EdgeX, we all know in the world. As a software developer, I always assume I have network connectivity, always, right? Because if I don't, it's a pain to manage, up and down and all that. Do you guys handle intermittent connectivity, low latency, disruptive connectivity, or are you like, that's outside the scope of that overlay network?
Yes, we do. I'm not going to say we do it. We do all parts of it. But there's parts we do today, and there's parts we're working on to do it even better. We have a whole bunch of use cases that we do in this space, particularly around military contractors and militaries themselves, where they're using ZT to, in their work. So one of the organizations we work with, I don't think it's verbatim, but it's more or less their quote: ZT is the best adherence to NIST 800-207, specifically, I think it's 3.1.3, which is how do I do overlay networks with software-defined perimeters. And for them, part of their requirement is I'm running a completely air-gapped network, and that's no problem, because you just put ZT in that environment. We also have our Cloud ZT product, which is the SaaS version. That one does require internet, but if you don't have the internet, great, we just use OpenZiti. There are a bunch of features that we've built into ZT to make it work nicely in those environments, which are, was it DILL, which I think is like disruptive.
Yeah, DDIL. Yeah, it's called DDIL. Yeah.
But there's more that we're working on. So one of the ones which is coming out like in weeks is HA. So you can have multiple controllers, and so you may have controllers in the cloud, you may have controllers on premise, and if that disconnects, you continue to have your network.
You continue to operate. I see. That's so
they're
important.
Using Gossip and Raft to share state, so that if it gets cut off, then it elects itself as the local leader, so that the system continues to run. And this is the key aspect for us. The design principle was we need to build a platform that can support any use case. And so in fact, just this week I've been working with an organization who, not going to name the vendor, but they've been using another zero trust solution, and they've tested OpenZiti, and they've gone, this is okay, but ZT does everything. Where there's some edge use cases that this solution can't support, ZT just supports everything out of the box, and that therefore makes it way easier for us. And this was our core starting point, because we didn't want to have to re-architect every time we came across an edge use case. We wanted to build a really solid foundation.
Right.
Sure, there's always development to do, but you start from that point of.
But you're not re-architecting the foundation. That's the key. Gotcha. All right. It's super cool. And we're out of time. If people want to find out more about OpenZiti and NetFoundry, where do they go?
So for OpenZiti, OpenZiti.io will take you to a little microsite, GitHub/OpenZiti. That's the repository, and there's a bunch of information in there. I work for NetFoundry, which is the company behind OpenZiti and CloudZiti. NetFoundry.io is our site. You can find me on LinkedIn or Twitter if you want to chat more. This is our mascot, because every open source project.
Yeah, you got to tell me about Ziggy here.
When we were creating OpenZiti, we were like, what would we call it? And we were like, open source, zero trust, open source, zero trust, OpenZiti. And then someone was like, Ziti is a delicious type of Italian pasta. And someone else was like, pasta mascot? And so Ziggy is a piece of pasta with a little hole inside, but you can't see that because he's dressed as a ninja, because you got to trust no one. And so we've got Ziggy, and always we've got Ziggy Stardust as David Bowie, we've got Ziggy as a spaceman, we've got Ziggy as a prince, all of these different outfits. In order to add some cool cuteness to him.
Oh, that's awesome, Philip. Thanks for coming on the show. This has been very enlightening. Most definitely, I'm going to dig into OpenZiti some more, and use it for some of my customers, because it fits the problem space so well. So thank you.
It's been a pleasure.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.